Okay, this is A1, evaluating logarithmic expressions. So this is part of the week 7 homework, and this is video 1. So we did most of this in class, but just in case you weren't there or you just need a refresher, this is what we're used to, exponents. You have b to the power of x equals a, so b being some base, x being the exponent, and a being the answer. If we want to switch that into logarithmic form, which is the inverse of an exponent, we would write it like this. Log, that b would end up here in the log base b, and then the answer a, or sometimes called the argument, would come next, and then it would be equal to the actual, that's actually the exponent in exponential form. That's our base, and this is our answer, or sometimes argument is what we say. And how we would say this, say log base b of a is equal to x. So that b is still called the base. Or maybe just log b. Okay, anyways, let's try this guy. 2 to the power of 4 is equal to 16. Wait, no? If we wanted to write that in logarithmic form, we would write the base is 2, the answer is 16, and it's equal to the exponent. So we could use logarithms to solve exponential equations, like when we have an unknown in the exponent, because that's what their equation is equal to. And sometimes we would find it useful to solve for an x, to solve for a variable exponent. Okay, so you should know how to go back and forth between exponential and log form. So if I give you this, you should know that, oh, that's my base, that's my exponent, and that's my answer. So you should be able to go back and forth between exponential and logarithmic form. So let's just try a random one. So let's say I gave you log base of 9 equals 2. So if I wanted to write that in exponential form, I know this guy's the base, so 3. This guy's the exponent, so squared. And this 9 is the actual answer, 9. So I can go back and forth between exponential and logarithmic form. Okay, so be able to evaluate logs. So we want to know log base 2 of 8, what is that equal to? So it would be equal to, it's like saying 2 to the power of what equals 8. So I know 2 to the power of 3 is equal to 8, so I know this is equal to 3. Base 3 of 27, what does that equal? Okay, so I know 3 to the power of 3 is equal to 27, so I know this would equal 3. Log base 4 of 16, so now I just think in my head, this is what's going on. Personally, I think 4 to the power of what will equal 16? And I know 4 to the power of 2 will actually equal 16. Then this one, log base 2 of 0. So now I'm thinking 2 to the power of what will equal 0? So this is puzzling because 2 to the power of what equals 0? Nothing. So we would say this is undefined. Because there's no exponent that we could put there that would actually equal 0. Because we know 2 to the power of 1 is 2, 2 to the power of 0 is 1, 2 to the power of a half is, I don't know, square root of 2. 2 to the power of negative 1 is a half. So we're never getting to 0. So that's not happening. So there's no value of x that's going to work. Okay, let's try this one. So 10 to the power of what would equal negative 3? So again, we have, this is like saying 10 to the power of what will equal negative 3. Also, your calculator usually does a log base 10, like even if you just have a log button, it's implied that it has a base of 10. So you could actually type into your calculator log of negative 3 and see if it tells you anything, and it'll probably say error because it's also undefined for this. because there's no value that we could sub into the exponent that would cause an answer of -3. So what you're going to find is, for all of these logs, they're really only defined for when x, for when our argument is greater than 0. So we just notice we don't like a 0 there, and we a negative number there, so we want that number, that argument, whatever you want to call it, we want that to be greater than 0 so that we're able to solve it. Okay, what about one like this? So log base 3 of 29. So 3 to the power of what would equal 29? I don't know. So I'm just going to go over here and just guess. So I know 3 to the power of 3 is equal to 27. So I know it's going to be close to that. So I just grab my calculator. And then I would say, okay, what about 3 to the power of 3.1? Alright, I got 30.13. It's going to be smaller than that. So then I could say, okay, what about 3 to the power of 3.01? So 3 to the 3.01 is 27.3. So I'm like, okay, what about 3 to the power of 3.05? And I get 28.5, so it's closer. Like, let's try 0.06, see what we get. 3 to the power of 3.06, 28.8. I'm just going to try 0.07. That is 29.2. So yeah, somewhere in between there. So we could say maybe 3.07. Kind of annoying to solve it like that though. So we're going to actually learn a better way to solve that. And we're going to using a change of base formula. I can give you a little preview now, but I'm going to teach it to you later. But what we can actually do is we can actually convert these both to a log 10 of 29 over log base 3. And if you type that in on your calculator, log 29 divided by log 3, it would actually give you an answer of 3.065. So this is called a change of base formula, and I'm going to teach it to you later. I'm just giving you a little preview. But it's going to help us solve these annoying ones where you're like, oh, I don't want to just keep guessing a bunch of decimal numbers. So there's actually a way that we can change any base logarithm to a base 10, and that way our calculator will actually be able to calculate it. Okay, so this was the end of video 1, so hopefully you can try those practice questions in the homework.